So, hello guys. So, how's your day? So, hope nakakasabay kayo sa mga lesson natin. Ha? Okay, for our topic for day is about, midterm na tayo. So, congrats. Nakaabot na kayo sa midterm. Okay, so our lesson for first lesson or first topic ngayong midterm is about linear algebraic equations. I'm sure familiar naman sa linear algebraic equations sa inyo algebra. Yes, okay, let's see. So our desired learning outcomes for this topic is for you to understand how to apply forward elimination and back substitution as in Gauss elimination. Okay, I'm sure ngayon nyo lang na encounter yung word na Gauss elimination. Okay, as we go over on the topic, so we will discuss that in details. Okay, from previous lesson, we already determined the value of x that satisfied a single equation, f of x must be equal to 0. So now we will deal with the case of determining the values of x1, x2, x3 up to xn that simultaneously satisfy a set of equations. So such system can be either linear or non-linear. So usually itong linear algebraic equations of three unknowns, madali lang itong i-compute using your calculator. Yung mga latest, meron siyang mga dyan, program that you can use up to three unknowns. Hindi ko lang alam ngayon, baka kaya na rin yung hanggang 4, 5, 6 na unknowns or maraming unknowns. Try nyo sa inyong mga calculator. So, an equation of the form ax plus by plus c is equal to 0 is also equivalent to ax plus by is equal to negative c. So, nilipat lang yung c sa kabila kaya naging negative. It's called a linear equation of x and y variables. Okay? Ax plus by plus c is equal to d is a linear equation in three variables, x, y, and z. So, thus, a linear equation in n variables is a1x1 plus a2x2 until makarating sa an xn is equal to b. So a solution of such an equation consists of real numbers. So c1, c2, c3, cn. If you need to work more than one linear equation, so a systems of linear equations must be solved simultaneously. Okay? So I think madali lang to para sa inyo. Mga solving of the unknowns. Ito yung mga bagay-bagay na masarap i-compute, yung mga unknowns. Usually sa board exam, laging lumalabas ng linear algebraic equation at saka matrix. Madali lang siya actually. So, just sit back, relax, and enjoy the video lecture. Okay? Ayaw ka ba? Kaya lang ninyo eh. So, next slide. So we have some non-computer methods for solving systems of equations. So for small numbers of equation, which is n is less than or equal to 3, linear equations can be solved readily by simple techniques such as method of eliminations. So linear algebra provides the tools to solve such systems of linear equations. So example, itong dalawang equations na to. So how will you solve it using algebraic equation? So you'll just eliminate, no? So using elimination method. So mag-eliminate lang ka or magput lang ka ng negative. So ito, napakadali lang para sa inyo to i-solve. Okay? But nowadays, so many access to computer makes the solution of large sets of linear algebraic equations possible and practical. So dahil nga sa advanced technology ngayon at mga available na mga software, so mas gaano pa karami yung mga unknowns, madali na lang siyang i-compute, di ba? Okay, before going to Gauss elimination method or the computer computer methods in computing the linear algebraic equation. So we'll first have some a little background on matrix. So refresher lang. So mabilisan lang tayo. So matrix notation and algebra are useful because they provide a concise way to represent and manipulate linear algebraic equations. So a matrix consists of a rectangular array of elements represented by a single symbol, as depicted in figure 3.2. Okay, so enlarge natin. Okay, so this is an example of a matrix. Okay, so A is the shorthand notation for the matrix. So ang matrix na pangalan niya is A, and Aij designates an individual element of the matrix. So our horizontal set of elements is called a row, and a vertical set is called a column. So the first subscript I always designates the number of row in which the element lies. So for example, ito, A1, 1. So ang kanyang I, this is 1. Kung dito na siya susunod na row na siya, 2 na, A2, then A3, 1, A4, 1. Okay, then sa next na column, A1, ito yung number ng row, kung ilan yung row, sa 1, 2, 3, 4. Kaya dito na siya na part, A2, kasi ang kanyang rows, ang column ay, ano na, 2. Okay, row 2, column 2. Then this is row 2, column 3. So always laging nauna yung row elements. Sunod lagi yung column elements. Okay. Then the second subscript B designates the column yun na. So for example, A23 Tapos na tayo. So the matrix in a figure has an n rows and m columns. So it's said to have a dimension of n by m or n by 3m. So it is referred to as an n by m matrix. So matrix with row dimension n is equal to 1, such as B, because this is the name of the matrix, is equal to B1, B2, B3, B4, B5, thus Bm. Okay, which are called vectors. And also it should be mentioned that there are times when it is desirable to employ a special shorthand notation to distinguish a row matrix from other types of matrices. So one way to accomplish this is to employ special open top brackets. So this is the bracket. So dapat naka-bracket siya. As in B. So matrices with column dimension M is equal to 1. So such as C is equal to C1, C2, C3. So column siya pababa. Kung B naman is siya ay row. Okay? Parang B stands for beam. So laging horizontal. C is for column, laging vertical. Okay? These are called column vector. So for simplicity, the second subscript is dropped. As with the row vector, there are occasions when it is desirable to employ a special shorthand notation to distinguish a column matrix from other type of matrices. So one way to accomplish this is to employ special brackets as in C. So matrices where n is equal to m are called square matrices. So pares lang yung value ng n saka sa m. So for example, a 4 by 4 matrix is this is a 4 by 4 matrix. So apat, 1, 2, 3, 4, 1, 2, 3, 4. Okay? So kung wala ito, pwede siyang 3 by 3 or wala to saka ito. So this is a 3 by 3 matrix. So diagonal consisting of the elements A11, A22, A33, and A44 is termed as the principal or main diagonal of the matrix. So this is the main. Okay. So square Matrices are particularly important when solving sets of simultaneous linear equations. So, for such systems, the number of equations corresponding to rows and the number of unknowns corresponding to columns must be equal for a unique solution to be possible. So, consequently, square matrices of coefficients are encountered when dealing with such systems. So, maliwanag kung ilang equations yung given, so yun daw ang number ng rows. Kung apat na equations ang given, so apat na rows. Then, kung ilan ang unknowns, yun ang number ng columns. Okay? Kung 3 lang ang unknowns, so 3 columns only. Then 3 equations. So, usually sa linear algebraic equations naman, lagi siyang square matrix. So, kung ilan yung number of equations, yun din yung same lang sa number of unknowns. Okay, we have here some special types of square matrices. So box PT 3.1. So there are a number of special forms of squares matrices that are important and should be noted. So this is symmetric matrix, where ij is equal to aji for all i's and j's, for example. So this part is the main or the diagonal elements. Kumbaga ito 1 and 1 parehas, 2, 7, 7. Itong rows na to and columns is parehas sa dito. Then the 2 and 2, yun. Kasi tinatawag na symmetric matrix. So usually it is a 3 by 3 symmetric matrix. So a diagonal matrix is a square matrix where all elements of the main diagonal are equal to 0. So, paano ba yun? Itong diagonal lang niya dapat equal to 0. So, diagonal matrix siya. So, A11, ganyan. So, note that where large blocks of elements are 0, they are left blank. So, yung mga values dito na elements is 0. Wala. Okay? So, note that so an identity matrix is diagonal matrix where all elements on the main diagonal are all equal to 1. So, as in this matrix. So the symbol I is used to denote the identity matrix. So the identity matrix has properties similar to unity. So upper triangular matrix naman daw, so all one where all the elements below the main diagonal, itong main diagonal, are all 0. So walang value. Okay, that's the upper triangular matrix, and we have the lower triangular matrix. So kabaliktaran siya ng upper, lower. So, ibig sabihin, yung mga nasa taas is all, taas na element is all equal to 0. Okay? Then, we have the banded matrix, has all elements equal to 0 with the exception of a band centered on the main diagonal. So, ito yung main diagonal, yung mga nakadikit daw sa main diagonal elements. So, yung wala, equal to 0. Okay, so the above matrix has a bandwidth of 3 and is given a special name, the tridiagonal matrix. So, tatlo ang kanyang diagonal. Okay, so in dealing with matrices, so make sure you are familiar with its operating rules. So, hindi siya basta-basta na-solve. So, dapat alam mo yung mga sequencing, yung plus, minus. It's just a simple of addition and subtraction. But dapat familiar mo sa mga rules. So there are rules in dealing with matrices. So 2 n by m matrices are equal if and only if every element in the first is equal to every element in the second. So that is A is equal to B if Aij is equal to Bij for all I and j. So this is an example of an equal matrices. So meaning every element is equal to the element of matrix A is equal to the element of matrix B. Okay. So addition and subtraction. So addition of two matrices, say A and B, is accomplished by adding corresponding terms in each matrix. So the elements of the resulting matrix are computed. So for addition, so example of this A plus B. So the elements of A, so the first element, example, so ang pag-add dyan, 1 plus the next element of matrix B, that is equal to C. So example, so 1 plus minus negative 1, ay 1 plus negative 9. So that is equal to plus value of negative 9. So ang ana ang pag-add sa matrices. So for these elements, so that is equal to 4 plus 2. Ganon. Then this element equal to 8 plus the element of matrix B. So ganon ang pag-add sa by element. Okay. And for subtraction of two matrices, say E minus F is obtained by subtracting corresponding terms, as in Dij is equal to Eij minus Fij. So both addition and subtraction are commutative. So A plus B is equal to B plus A. And addition and subtraction are also associative. That is A plus B plus C is equal to A plus B plus C. Okay, so for subtraction, so ganun lang din. Parang pareha sa una. So by terms, friend. And for the multiplication, so the multiplication of a matrix A by a scalar G is obtained by multiplying every element of A by G. So if the D has some elements of A11 up to A and M, so tanan na is multiplied by G. Okay, so the product of two matrices is represented as C, which equals to A times B, where the elements of C are defined as C box PT 3.2. Cij is equal to the summation of AIKBKJ, where N is equal to the column dimension of A and the row dimension of B. So that is the Cij element is obtained by adding the product of individual elements from the ith row of the first matrix. So in this case, matrix A by the jth column of the second matrix B. Okay, so what does it mean? How will we obtain the product of the two matrices? So this, for example, so we will compute for the product of uh, matrix A to be, ba't di lumalabas? Automatic. Tayaw. Okay. Why? Okay, so ito. So, ang pagkuha sa product is first matrices with regards to second matrices. So, we have to get first the row of the first matrices. So, itong row multiplied by the column of the second matrices. So, for the first element of the product for matrices C, so this is the product of matrices A and B. So, paano natin kukunin yan? So, that is equals to the sum of the product. So, first, kunin natin yung first element sa A, that is 1, multiplied by the element of B, plus, okay, 4 times second column, the second row, plus the third column of A times the third row of matrix B. So that's it. Okay, so that's it. Then ang sunod, So this row multiplied by the second column, that's equal to 4 times 2, yeah, equal to plus, ay na mali. So that's equal to the first row times the second column. Ito. Okay, plus ito na naman times itong value na to, and plus 8 times 10. Okay, so ganun lang. Then sunod sa product, so yan times this plus 4 times 8 plus 8 times 11. Enter. Okay, so that's it. And for the next term, so dito tayo magpo-focus na sa gitna. Okay, so that's equal to 2 multiplied by the first column of P plus 2 times the column plus 7 times 3. Okay. So, yun. So, basta pag matrix A, yung unang matrix, dapat yung row ang i-multiply sa column ng matrix B. Okay. So, ganun lang. I-continue lang nyo lang times 2 plus 2 times 7 plus 7 times 10. Okay. So, ganun lang ang product. Medyo nakakalito lang, pero dapat lang tama lang yung sequencing ninyo. Okay, so however yung step na yon is pwede lang kung pares lang sila ng number of columns and rows, or kung pares sila na square matrix. However, paano kung hindi sila parehas ng columns sa rows? So ano ngayon ang gagawin? So the next figure, box PT 3.2, will show you how to get the product of the two matrices of hindi unequal or hindi parehas ang columns and rows. So example in this case, so we have a 3 by 2 X matrix to 2 by 2 Y matrix. So kung natin siya ng product, so let's say Z ang kanyang product. So paano natin siya gagawin? So we have to multiply first the row multiplied by its the column of the second matrix. So para mas madali, ganito gagawin natin. Ito lilipat natin sa top. Okay, so kung natin yung product, so this is the product ng tatlo, 3 by 2. Okay, so the first element, the rows is equal to 3 multiplied by the column times ito plus element times 7. So that's it. And for the next element, so we will get the 8 times to so that's equal to 8 multiplied by plus by 7. So that's it. And for the next, that is equals to 0 times 5 plus 4 times 7. Okay, so ganun lang. Then sunod 3 times 9. So, second ano tayo? Second column ng matrix Y. So, plus times 2. There. Okay? Until ganun ulit. 8 times 9 plus 6 times 2, which equals to 84. Then next, 0 times 9, 0 plus 4 times 2, that is equals to 8. So, ganun. Okay? So, note that how this simple method makes clear why it is impossible to multiply two matrices if the number of columns of the first matrix does not equal to the number of rows in the second matrix. So, also note how it demonstrated the order of multiplication matters. That is, matrix multiplication is not commutative. So in this figure, figure PT 3.3, if the dimension of the matrices are suitable. So matrix multiplication is associative and distributive of matrix A times matrix B plus matrix C is equal to the product of the matrix A and B plus product of matrix A and C, or the other way around. But however, multiplication is not generally commutative if that is the order of multiplication is important. So sa division naman, matrix division is not a defined operation. So however, if a matrix A is square and non-singular, there's another matrix A raised to negative 1 called the inverse of A. So for which matrix A times the inverse of the matrix A is equal to the matrix A inverse times A, which is equal to I. So thus the multiplication of matrix by the inverse is analogous to division, so inverse. So in the sense that a number divided by itself is equal to 1. So that is a multiplication of matrix by its inverse leads to the identity matrix. So the inverse of a two-dimensional square matrix can be represented simply by this expression. Okay, so that's our little background about matrix. So we'll use these rules in computation of linear algebraic equations. So by Gauss elimination method. Okay, so that's for the part 1.